All right, good afternoon, everyone. Hope you guys can hear me okay and see my screen. Hope you guys had a nice and restful break. Okay. Okay, so bell schedule for this week. All the classes will be 50 minutes with 5 minutes between each class, which means that we'll be ending 7th period before 3:30. And then the last 45 minutes is just really for help sessions or office hours for students and teachers. Hopefully you guys are able to see the packets as well as the calendar. All this is on my website. We're going to be starting our unit on matrices today. Okay, so let me go over our calendar for this week. We're starting matrices today. Should be easy. It'll feel easy. We're just adding and subtracting and doing scalar multiplication. Go through some vocabulary. Tomorrow we'll be dealing with multiplication. Multiplication is going to feel a little messier. We'll spend 2 days working on that. And then on Friday, we're going to talk about inverses. And that will allow us to get through all the material that we need for our quiz. So we'll spend Monday and Tuesday reviewing, and then quiz will be on Wednesday. Okay. We have map testing Thursday and Friday for 9th and 10th graders. So for those of you who are not 10th graders, many of you will just use this as study hall, period. Okay, and then we'll begin the rest of, we'll continue with the rest of our matrices unit after MLK weekend. All right, so hopefully you guys are able to print out the packet, or if not the packet, you can at least print out the first few pages. We're going to go to 5.03. So, sorry, 5.04. I know that it's a little doesn't quite match, but we're going to work all the way to 5.04. Okay. Now, in your packet, and also, if you are just printing out page by page, I will have a full packet for you when you do return next week. Okay, so the first page you're going to see a series of summary, and this summary sheet is also on the back of the calendar. Okay, so all this is on all this is on the page, the matrices page on my website. Okay, so okay, so let's begin our notes. Okay, so intro to matrices. A matrix is a rectangular array of numbers. It's just think of it as how you would if you imagine Excel, right? Just have a series of numbers, each with their own kind of space, right? So this is first row, first column, first row, second column, first row, third column. Okay. So the uses for a matrix it's used to solve systems of equations. We're going to really get to that next week. If we have a set of data with another set of data, we can use matrices to kind of help us organize these records, and also just to record data. Okay. So here's an example of a matrix. This matrix has a specific dimension. Okay. Dimension is the size of a matrix. So the dimension is measured as rows and columns. So this is a 2x3 matrix. Okay. Okay, the reason why this is a 2x3 matrix is because we have two rows. So this 5, 0, -1 is part of row 1. All right, -3, 1, and 9 is part of row 2. All right, so we have two rows. Rows goes from left to right. And then we have 3 columns, right? So columns goes vertically. So here, this piece is 5 and -3 is column 1. 0, 1 is column 2. And -1, 9 is column 3. So we consider this a 2x3 matrix, 2 rows and 3 columns. Okay. Elements are values in the matrix. Okay. And if I want to specify a specific location where that value is located, I can use this notation. So elements are values in the matrix. So the location are described as rows followed by columns. So let's say for matrix A, we can use brackets to indicate that we're talking about matrix A. And if I want to find in matrix A, I want to find the element located in 1, 3. So the first number is going to tell us which row to look. And the second column, or second number, is going to tell us what column is located. So if I want to find the element located in matrix A, or in matrix A located in row 1, column 3, we just go to find that location, right? So row 1, we're looking at 5, 0, -1, but we want to find column 3. So row 1, column 3. Oops, sorry, row 1, column 3. All right, it's going to be -1. Right, row 1, column 3 is -1. All right, so some more examples here. This matrix B is called a column matrix because there's only one column. Okay, so here we have the numbers that go from left to right is a row. So this is row 1, row 2, row 3, row 4, but it's only along one column. So this matrix B is a 4 by 1 matrix. Okay, it says what are the dimensions of matrix B? It's a 4 by 1 matrix because we have 4 rows. And only 1 column. Okay, what about a row matrix? A row matrix would just mean 1 row but multiple columns. So here it says create a 1 by 3 matrix C. Okay, so I'm just going to create some random numbers here. But basically, I'm only going to have 1 row, but I'm going to have 3 columns. So I can just choose some random numbers here, 4, 6, and 9. All this is along 1 row, but we have 3 columns because we have column 1, column 2, and column 3. Okay, so now what about a square matrix? We want to create a 4 by 4. Let's create a 4 by 4 square matrix D. So that means I want 4 rows and 4 columns. Okay, so again, I'm just choosing some random numbers. You guys can have a different set of numbers as long as the dimension is correct. Okay. This is a 4 by 4 matrix because we have row 1, row 2, row 3, row 4. That's telling us that's where that first number is coming from. There's also 4 rows, right? Row 1, row 2, row 3, row 4. 4 by 4 square matrix. Okay, any questions? First page. All right, let's go to next page. Now we're dealing with operations. So operations, additions and subtractions between matrices can only be done with matrices that have the same size or basically the same dimensions. Scalar multiplication, which I'll talk about in a moment, is basically just distributing a number through a matrix. Can be done with matrix of any size. Okay. Scalar matrix just means we're multiplying by a number. Tomorrow we'll talk about multiplication between matrices. That's a little bit more complicated, but a scalar multiplication is going to be easier. So just kind of show a quick example of a scalar multiplication. Let me highlight this and put an example above. So let's say you're asked to find 2t. So 2t, we see how we have matrix t here. If I want to do 2t, all that's saying is I'm going to multiply 2 through every element within matrix t. So here's an example of a scalar multiplication. Okay, so if I want to find 2t, I just can take 2, distribute it through each of the elements, multiply through each of the elements of my matrix T. So just multiply 2 through every element. So I get negative 10, negative 8, 2, 14, negative 16, and 8. Okay, accidentally just did this example here, so 2t. Okay. Now, if I want to add and subtract matrices, I have to make sure that if I want to add and subtract matrices, that they're actually the same dimensions. So if I want to add S and U together, we have a 2 by 3 matrix with a 2 by 2 matrix. These are not the same dimensions, so we're not going to be able to add these two matrices together. So this is not possible. Okay. If I want to subtract S minus T, notice S and T have the same dimensions, right? They both have 2 rows and they both have 3 columns. I'm going to take every element and subtract with the corresponding element within each matrix. Make sure, though, that we understand this minus is outside T, so there may be a double negative going on. So we want to make sure that you keep track of additional negatives if there's any. Okay. So I'm going to write this out. So I'm taking matrix X, sorry, matrix S. I'm going to subtract matrix T. Okay, so here's my new matrix. 2 minus a negative 5 will give me 10. I'm sorry, 2 minus negative 5, my bad. 2 minus negative 5 is going to be 7. Negative 1 minus a negative 4, that's negative 1 plus 4, so that's 3. 3 minus 1 is 2. Negative 4 minus 7, negative 11. Negative 2 minus a negative 8. The two negatives become positive, so negative 2 plus 8 will be 6. And then negative 8 minus 4 will be negative 12. Okay, any questions here? Two T, we kind of did that as I was going through that example. So I'm taking 2 and multiplying it through every element within matrix T. All right, next one, 1/2 times U. So I'm going to take 1/2 and multiply it through every element within matrix U. So this will give me 9 over 9 times 1/2 is 9 halves. Negative 3 times 1/2 is negative 3 halves. Negative 2 times 1/2 is negative 2 over 2, which I can reduce to be negative 1. And 1/2 times 0 is going to be 0. All right, any questions so far, adding and subtracting and dealing with scalar multiplication? All right, so continuing with the bottom half, use matrices A, B, and C to solve for x. So here, x equals 2 times b. So I can just do what this is telling us to do, right? Just multiply 2 through matrix B, and whatever the result of that is matrix X. Okay, 2 times -4 is -8. 2 times 12 is 24. All right, so here, a plus x equals c. I want to solve for matrix X. So I'm just going to do some addition and subtraction here. If I want to get x by itself, I can subtract a from both sides. So x is equal to c minus a. So if I want to get matrix X, I can just take matrix C and subtract all the elements, all the corresponding elements in matrix A, and the resulting matrix will be matrix X. And also we see that C and A, they both share the same dimensions, right? They're both a 2 by 2 matrix. Right, careful with the negatives here. So -2 minus 3 is -5. 8 minus 0. 5 minus a -1. We got to worry about the two negatives there canceling each other out. That gives basically is 5 plus 1, which is 6. -6 minus 7, -13. All right, questions? All right, so here's classwork on page 5, and give you guys a chance to try each problem, and then I'll follow after you guys try. So number 1 is to state the dimensions of each matrix. Remember, the first number is number of rows, the second is the number of columns. Okay, try number 1. Okay. 2 rows and 2 columns. So we have a 2 by 2 matrix here. All right, number 2. All right, got row 1, row 2, row 3, 3 rows, column 1, column 2, so 2 columns. 3 by 2. First number tells you how many rows there are. Second number tells you how many columns there are. Okay, it says find the value of each element in matrix A. Now, we don't want to think of this as A22. This is actually 2, 2. The first number is talking about which row to look at, and the second number is telling which column to look at. So we want to find the element that is located row 2, column 2. All right, so row 2 is going to be the 24, 36, negative 22. We want column 2, so this is column 1, this is part of column 2, and this is column 3. So the element located row 2, column 2 is going to be 36. Okay. A31 means we want to find the element in matrix A that is located in row 3, column 1. So row 3, this is row 1, row 2, row 3. So within negative 5, 15, 4, and 29, we want to find column 1. So column 1 is this negative 15 here. All right, let's go through each of these problems below. If we're going to be adding and subtracting matrices or multiplying and adding, if the matrix does not exist, write impossible or not possible. Q plus R, so Q plus R looks like these are both the same dimensions. They are both a 3 by 2 matrix. All right, what about T minus R? Can we add and subtract these two? Not the same dimensions, right? You have a 2 by 3 matrix versus a 3 by 2 matrix. They need to match, even if the rows and columns are flip-flopped, they need to match exactly. So if they don't look exactly alike, we're not going to be able to multiply. Sorry, we're not going to be able to add or subtract. Now, tomorrow, when we talk about multiplication, we have different rules for multiplying, but when we're adding and subtracting, the dimensions have to be exactly the same. T minus S, however, we can do that, right? Because T and S, they both have the same dimensions. So all the corresponding elements within each matrix, we're going to subtract them, make sure that, again, you got to keep track of your negatives. Sometimes you may have a double negative, which will change the sign to be a positive. Three plus 2, 7 minus 1, 4 minus negative 6, that's 10. Negative 9 minus 14, and then 16 minus 8. Okay, good so far? 2R plus Q, a couple things that's going to go on here. We're going to deal with the scalar multiplication, get that 2 to distribute through every element with an R, and then we can add the results with Q together. So this is safe. These are both matrices that have the same dimensions. So we know that even if we multiply 2 through R, we're still going to have a 3 by 2 matrix, so we're still good. So let's deal with 2R first. So 2R, I'm going to multiply 2 into every element within R. Okay, so there's the result of my 2R plus Q Okay, so here's my result. Hey, I'm adding, right? So I'm not changing the signs here. Okay, any questions? All right, number 9, 1/2 t plus s. There's 2 ways you can do this. You can distribute 1/2 through t and 1/2 through s and add them together. I just think it's easier to deal with the fraction at the end. I would rather just add the 2 matrices together and then deal with the fraction at the end. I just find that to be a little bit cleaner, a little bit easier. So I'm going to deal with t plus s first, and then I'll multiply the 1/2. However, if you distribute the 1/2 through first and then add the 2 matrices, you'll still get the same thing. It's not wrong. I just find it a little bit cleaner and easier to let's just save the fraction for the very end. Okay, so I'll deal with t plus s first. So I'm going to take each of the elements within t and s and add those together. Okay, so there's the result of matrix T and S added together, and then I'll just deal with that 1/2 at the end. So I'll multiply 1/2 through each of the elements. So 1/2 times -6 is -3. 1 times 1/2 is just 1/2. 8 times 1/2 is 4. -2 times 1/2 is -1. 5 over 2. 5 times 1/2 is 5/2, and 24 over 2 is 12. All right, questions? Okay, use matrices Q, R, S, and T to solve for X. If matrix does not exist, write impossible. I'm just going to try to get X by itself algebraically, and then we can deal with the matrix. Okay, so here I want to solve for X. I want to really move that 1/3 to the other side. So a way for me to undo that 1/3. I could divide both sides by 1/3, but it's just cleaner and easier to multiply by the reciprocal, right? So I'm going to just multiply both sides by 3. Right? I know that 3 and 1/3 will cancel out, and I can just move that 3, distribute through the other side. So X is really just 3 times Q minus R. Okay, is everybody okay with that? I'm dividing by 1/3, which is the same thing as multiplying by 3. It's just a little bit cleaner and easier to multiply by the reciprocal rather than dividing by the fraction. Right. Okay, so Q minus R. I can subtract these two first, and then I'll distribute the 3 through. You can also distribute the 3 through individually first and then subtract, whichever way. I just find it a little bit cleaner to subtract these two first and then deal with the 3. So I'm just going to subtract Q minus R first. Right, careful with the sign change, though. -6 minus a -3. That's -6 plus 3. 2 minus a -5. Okay, finally, just distribute that 3 through. Okay, so this is matrix X. I subtracted Q, matrix Q minus matrix R, and then distributed 3 through. Okay. Hopefully that's what you guys got. Let me know if you see something that is different or if I made a mistake somewhere. Okay, number 11. I want to solve for x, so I think an easy way to get that x by itself, I'm going to move that x to the right side to make it a positive x, and then I'll subtract t to the left side. So if I do 3s minus t, I can get x. So I'm just going to rearrange it just to get whatever it takes to get that x by itself. So now that I have my equation in the correct places, I can now involve matrices to get that matrix X. So I'm going to take 3, distribute it through matrix S, and then once I get that, I can do the resulting matrix minus matrix T. Okay, I'll distribute the 3 through first. Three times 14 is 42. Okay, so resulting matrix 15 minus -11. Okay, number 12. I can distribute or I can divide both sides by 2 if I wanted to here. So divide it by 2. Same thing as multiplying by 1/2, right? Because I want to get that x by itself. So q minus x is equal to negative 1/2 t. If I move that x over to the right side, get that positive x going, I get q plus 1/2 t is equal to x. But I think we're running into an issue, right? Matrix Q is a 3 by 2 matrix. Matrix T is a 2 by 3 matrix. So these are not compatible. We're not going to be able to combine those together. So this is not possible. Okay, dimensions are not alike. Okay, number 13, word problem here. So Jessica took her 2 children to the community swimming pool once a week for 6 weeks. The daily admission fees are $4.50 for a child and $6.75 for an adult. Write a 1 by 3 matrix with scalar multiple that represents the total cost of admission. What is the total cost? So there's 3 people, right? We have Jessica and her 2 children. And we know that each child is going to be have to pay will be $4.50 for each child, but then Jessica will be $6.75 for her admission. Okay, so what if we just created a 1 by 3 matrix, right? 1 row, 3 columns. They each represent the cost per person. But we know that Jessica is going to take her. They're going to go to a community swimming pool once a week for 6 weeks. So they're going to have to go 6 times, right? So each time they go, they're going to be charged this amount. So all I'm going to do is I'm going to multiply it by 6, right? So scalar multiple. So this is how much it costs per person for one-time entrance. But if they're going 6 times, then we're going to multiply that each by 6. So 6 times $4.50 is $27. $27, and then $40.50. So the total cost, we can just add these together, right? 27 plus 27 plus $40.50. Okay, any questions? Okay, so just like last semester, I'm not going to have any homework. We're just going to be going through, you know, if you're just following along with notes and just doing everything in notes, then you're going to get full class credit and homework credit. So 5.01 practice, we got through it all. Okay, so next week when we return, maybe on if not Monday, then Tuesday, I'm gonna walk around and just check each of your pages that you've completed the pages for class. Okay, and I'm also going to upload this the video and the key to the website. So if I'm going too fast or if you haven't had a chance to copy it down, I will upload it so that you guys can see and follow along. Okay. All right, any questions? All right, have a great day, everyone. I will see you tomorrow.
Have a great day.
Okay, thanks, guys. Have a great day.